This new line has increased our throughput by 20%. We need to monitor the welding consistency closely. So as you can see, the new system increases our efficiency by almost 20%. That's a huge improvement.
Strength index 98.6. Looks good.
Monitor the temperature at manifold 7.
Reading stable, holding at 5th and 100.
Looks like we have a slight pressure drop in sector 7.
I see it. Let's monitor it for the next cycle. I've completed the scan. The results are unexpected.
Measurements are reading stable on the laser alignment.
Okay, applying final torque sequence now. Looks like we have a green status.
Okay, I'm plugging the new cable in.
All right, and now try to move its arm. Let's see.
Diagnostics complete. All systems online.
Check the pressure reading on actuator 7.
Reading stable. We have full articulation.
Okay, begin initial diagnostic. Movement protocol engaged.
Are the level 3 scans complete on this sector?
Almost. We're showing a 98% match with the archival data.
Look at the phase variance here. It's negligible.
Yes, 99.2%.
Did you see the oscillation on that last component?
Yes, the stabilizers compensated immediately.
Unit A is secure. Data transfer commencing.
Excellent work. The calibration looks stable.
Okay, aligning the module for final insertion.
Confirmed.
It's localized to the epsilon grid, right here.
Yes, the delay is minimal, but we need to compensate.
At 12.4 kilometers per hour, the energy consumption spikes. We should cross-reference this with the stabilization logs.
The precision metrics are holding at 99.6%.
Exceeds the target parameters.
The precision on this joint is excellent. This is exactly the standard we need for the new line. Well done.
An impressive achievement. It seems we are ready for the next phase.
The output here is inconsistent with the baseline metrics.
I agree. If you look at the tablet, the thermal readings peak